Respected Principal Dr. J. Hussain, Vice Principal Mr. Anish Babu, Administrative Manager Mr. Zubair, Dr. K. Najib, HOD, Department of Computer Science and Engineering, heads of other departments, our resource person for today, Mr. Shahad, faculty members, participants from various institutions joining us online, and dear colleagues, good evening to all of you. On behalf of the organizing team, I extend a warm welcome to everyone for the national level 7-day online faculty development program on machine learning. It's great to see participants from different institutions coming together for this program. Before we begin, let me share a few words about the organizing department and the objectives of this faculty development program. The Department of Computer Science and Engineering at MEA Engineering College was established in 2002 and is affiliated to APJ Abdul Kalam Technological University. MEA Engineering College is the first NAC accredited self-financing engineering college in Malappuram district, and our departments of CSE, CE, and ME hold NBA accreditation. The department focuses on both technical depth and innovation with a curriculum that balances hardware and software design, covering areas like image processing, database management, and computer architecture. We are supported by dedicated faculty and state-of-the-art facilities, including a specialized research lab and computing hubs with over 180 workstations. The objective of this 7-day online faculty development program on machine learning is to bridge the gap between theoretical machine learning foundations and practical laboratory integration in alignment with the 2024 KTU syllabus for PCCST 503 and PCCSL 508. The program aims to strengthen faculty expertise and research output to meet institution accreditation standards and to equip educators with modern AI productivity tools and advanced computational techniques for high-quality instruction and cutting-edge research. I now request Anish Babu sir to kindly inaugurate the program and share a few words with us. Sir, please.
Hello, good evening. I hope it is audible.
Yes, sir.
Okay, thank you. Respected Principal, Dr. J. Hussain, sir. Respected Manager, Zubair, sir. HOD, Najib, sir. Faculty members of MEAEC and other institutions. As the introduction, we have seen that it is FDP, Faculty Development Program on Machine Learning. And I hope that this faculty development program will be helpful for the teachers over who is handling the machine learning subject so that they can be expertise and they can be a very expert in the subject and can deliver the lectures to all the students across the country. And I hope that this faculty development program will enhance the knowledge behind the knowledge as well as the theory and the practical knowledge behind the machine learning. And I wish all the participants to have explored in this subject, and I congratulate all the coordinators and the people who are behind the faculty development program who have organized this, and especially very thanks to the HOD Department of Computer Science and Engineering Department for organizing such an event. So on behalf of MEAEC, I officially inaugurate this 7 days faculty development program on machine learning. And I welcome all the participants from our institution and outside the institution for this program. Thank you.
Thank you, sir. Now let's move to the session. Today marks the first day of our FDP, and we are starting the session Learning to Learn Foundations of Machine Learning. We are honored to have Mr. Shahad with us today. He is currently pursuing his PhD at the Indian Institute of Information Technology, Kottayam, and also serves as an assistant professor at Jain University, Bangalore. His research focuses on machine learning and artificial intelligence applications, and his experience in both research and teaching gives him a strong ability to explain complex machine learning concepts clearly. We are looking forward to learning from his insights and practical perspective today. Over the next 7 days, this program will take us through both the theory and practical aspects of machine learning. I'm sure today's session will set a strong foundation for the days ahead. I request all participants to stay engaged, ask questions, and make the most of this opportunity. With that, I now invite Mr. Shahar to take over and begin the session. Thank you, and let's get started. Over to you, sir.
Thank you, Rasha. So first of all, I would like to thank the all people who work behind this wonderful FDP and the all entire MEA family, the management, the principal, HOD of the department, and obviously the coordinators who work so hard to make it happen. So without making much delay, first of all, I would like to say sorry because I don't have power right now. It's just gone a minute back. So I'm not on my video right now. We are directly moving into the topics. So I hope I'm audible and I see screen also visible. Okay. 1 second. Can you see my screen?
Yes, sir.
That's okay. So before we are moving into any subject, it is really important what actually the subject explains. So before starting the subject, I have to have an idea of who are the participants in the particular FD. Generally, it's a faculty development program. So we expect that all will be faculty and few will be researchers and some will be industry people. And there will be a motive behind all these participants. And I assume that you are aiming to make an concrete idea on this machine learning course. And this machine learning course is coming into the next semester and you have to cover the entire syllabus in an effective way so that students are very new to the machine learning subject and they will get more idea and they feel like enthusiastic and they can start learning the machine learning from the foundations. And with that assumption, your main motive is to teach the student in the upcoming semester, and in that way I'm proceeding with my presentations. So I've gone through the syllabus. This is the syllabus that I got from the coordinators. Actually, I'm not going through the entire syllabus or in the way of syllabus, but I have to give a strong foundation for the entire course. So I gone through the syllabus and I see that many of the contents were already discussed in the previous regulation. I think it's in 2020, 2021. I also had the same course and many of the contents are same and few of them are updated. So the way I'm going to start today's session and wind up today's session will be like a foundation and approach. How we can teach the student this particular course and how we can make them interesting. So this is the main aim, machine learning foundations through a human lens. This is what or the title of today's topic. Whatever we are discussing today will be with the help of introduction, the type of data, machine learning process, the types of machine learning, and we will conclude with the overall process. So let me start from the first question. We are actually born without any specific knowledge, or we are here in the earth without any kind of special rules, or there is no much preconditioning for all of us. And what we are learning is by different ways. We will discuss that in detail. You can say in machine learning terms, maybe like supervised and unsupervised reinforcement. We are using different terms. So for the beginning, let us think how we learn to live in this different or a complex world. We are learning a lot of things. How we learn it. So from that point you start. We are human beings. And we learn many things. We are learning, we learned, and we will learn. So before learning anything, how we start learning. So what we actually do, or what we are doing right now, this is what we have to know first. Then only we can move into the machine learning terms or concepts. From the terms or the knowledge is mapping from known to unknown. We are finding something new. It's not from the air. It's not from the empty place. We are developing it. Something is there. So we are mapping into something unknown. So this is what we are doing in normal scenarios. Now you imagine how you learn your mother, how you recognize your mother. So here is a simple example. I just given a photo, how we started to recognize our mother. Nobody teaches any rules. No one programmed this. And we are not exactly measuring the geometrical distance between her eyes or her jaws or any other computer related using any. You can hear me, right? Hello? You can hear me, right?
Yes, sir.
Russia? Okay.
Yes, sir.
So this is exactly the machine learning also works. There will be some kind of data, and we are trying to make the machine learn something from the data instead of exclusively programming something and getting some output, specified output for the specific input. It's not like that. We are learning through the experiences. So we'll go to each and every terms in detail with the human perspective or the way humans are learning. So this is what the humans are doing, and we are trying to map the same thing into the systems and in different ways, how we are doing in different ways. This is what we are discussing in the next slides. Okay. So basically, we, the human beings, learns through experiences, and we are not learning any special kind of algorithms, and we get the knowledge from this kind of experiences or the data. The same thing we are doing with the systems. The data will be there, and we are using some kind of algorithms. It can be a kind of regression algorithm, or can be classification algorithm, clustering algorithm, or whatever the kind of algorithm we are using. We are supplying that data into the algorithm, and the model or the algorithm will learn what exactly there in the data or the pattern behind the data. Based on this pattern, we can either go for a prediction, or we can go for a classification, or we can go for a clustering. So the learning improves when the data is applying more and more. And there also we have some rules. We have to follow the rules. It's not giving some random kind of data. Definitely we have some rules. So best data, if you are supplying more and more, it will learn more and more, and it will be perfect model once it is coming deployment. So the experience, we are saying experienced person. That means he gone through different kinds of experiences or different kinds of scenarios, case studies, data sets, or different kinds of issues he faced, and he know how to handle a kind of learned model. So this is what we are trying to build in the machine learning subject. Then we may have some doubt why this particular machine learning becomes this much popular in these days. It's not a new subject. It's not something new. Even AI also a new one. It's established long, maybe 50 years back. But why it didn't get much exposure? What happened in the previous history? So actually, there are ideas, there are concepts, but we don't have much resources. Even with the data, even though we have everything, without resources, we cannot execute, we cannot make it happen. So the data explosion, the students or kids, you can understand how the current kids or the new babies are learning to live in this digital era, and how the older people are struggling with the new era. So the data explosion, there are enormous amount of data which is generating in various ways. According to that data, we understand that there are a lot of opportunities and chances to make something from this particular data. So why we can't utilize it? So utilize that, the restriction was in terms of power or in terms of resources. Once the resources are available, we try to use the existing mathematical algorithms, or we build something over the mathematical concepts. We developed it, we moved from ML to DL, DL to LL, LLM to agents, and all this way we are progressing. All these are happening just because we do have enough support in terms of resources. If we don't have resources, your idea will be vain. You cannot execute it, or you cannot establish something new with the bulk data or the data which we are having. Okay, this is the reason why it came into existence or it became popularized. Availability of data, the resources availability, and the better algorithms, all available in this recent past. So the things are emerging fast and things are coming into our hands. Now let us move into the traditional programming and machine learning programming differences. We are the programming machine learning approach, or the traditional programming approach is entirely different from, or machine learning is entirely different from traditional programming. Actually, we know we have done our BTech or MTech or whatever the education qualification we obtained during the all days or the normal programs. We are writing some code, we are giving some input data, the program will execute, it will give a result. There is no doubt in that. Suppose the same data you are giving 100 times or 1000 times to the same program, it will give the same result. There is no change in the result. That is the main aspect of the traditional programming. We cannot expect something new from the existing program. If you want to get something new from the existing program, you have to edit it. You have to change the code. Then you can expect something new. Otherwise, if the data is same, the same program, you can expect the same result even for the 1000 times or 1,000,000 times. But now the things are changed. We started supplying data. We make the model and we taught the model what is there in the data. Based on the data, you do something more accurate. or something you have to change based on the data which you are receiving. So your current data, based on that, we build a model, and if we are supplying more data again and again, we are retraining the model and we are getting fine-tuned results. Actually, this is what we, the human beings, are doing in the real life, in the human senses also, or human way of learning things. It's not just one kind of thing. We are going to explain one by one, different kinds of data and all. So even the human beings are following the same thing. Whenever the data is coming into our brain or some in front of you, you will automatically learn, or you will update your trained model, and you will become more and more accurate if we are passing through different strategies or different data or different situations or whatever it is. If you are experiencing more and more data, you are becoming more and more perfect. But the same thing we are applying into the machine learning approach. The data will be there, result will be there. Once the data is improved, learning will be more, output will be more perfect. It means if we are giving same data again and again, you may not get the same result. You may get better result. Sometimes in the previous case, it may say the value as 22, and in the execution, after some time, it feed with more data. It may say 23 point something or whatever, something maybe less or more. It may be more accurate, maybe more accurate. But there is a chance, or mostly the value will change according to the training process. This is the main difference. Output is also considered on the data size or the number of experienced data means experience. So this is what the main difference. In traditional programming, you can expect only one result for one particular input, but for machine learning tasks, you can expect different input in different scenarios according to the input supplied, the data set we used for training purpose. So this is a basic difference. Okay. Now, we have to think of data. Let me bring your attention into the human perspective. You are human beings, or we are human beings. We have capacity to read or take data in different formats, right? We have capacity to retrieve data or read data as numerical data, sensor data, or a kind of textual data. We can retrieve numerical data, we can retrieve or read textual data. We can take visual or images, videos, even we can smell, a kind of sense, touch, hearing, audio. So the first thing, whenever we are starting machine learning subject, we have to understand what actually we, the human beings, are doing for different scenarios. Suppose somebody is asking, what will be the number of seats the Congress will get in the upcoming election, maybe whatever it is happened. Somebody will ask before the election days. So people are saying some values. So they are actually collecting something from somewhere, a kind of data-based forecasting they are doing, and they are saying something based on the numerical kind of data. Or they are using some kind of textual readings. So human beings are capable to do all these machine learning tasks, but the thing is accuracy of predictions or accuracy of classifications or accuracy of clusterings. It may not be up to the mark. So here in this machine learning subject, whatever the subject, whatever the use case you are considering for the lab purpose or for the explanation purpose, all will be data, and that data can be any one of the format that actually we, the human beings, are normally processing. You can take any of the example. What kind of data we are normally working with? Normally, the simplest way, the easiest way, we are using CSV files or Excel files, or you can say SQL tables. So these tables contains numerical values generally, We can expect different things also, but generally CSVs and all, we can expect more kind of numerical values. So the numerical values are recorded in the columns, or you can say rows. It will have some title, column title. We are calling it as features in the machine learning terms. In databases, we are calling it as attribute, but here we are using the term features. So the numerical data we can expect when we are doing or we are going to do some machine learning task. Next option, we can expect some kind of textual data. We are already experienced and we are experiencing. Same the human beings are using. Then I related, either video or images. Again, another important thing is audio. So whatever we are processing, the human brains are processing, we are trying to make it happen with the help of computers. Why? Because it is more accurate and tireless work it will do 24/7, and there is no much requirement of much energy in terms of power we need, but there is no much worries about the feeding of food and all. So we can expect a consistent performance, more accurate performance. So we are focusing on the things should happen with the systems. So here, when the data we are retrieving, we may feel like it's very easy to extract the contents from the data. So it's not about the data. Even though the data is there, a huge amount of data is there, a machine learning expert or a person who is working in machine learning or data science or something related to that, they must first understand what actually the data is. And the difference of data, information, and insight. These three should be very clear. Whenever we are going to the class and all, you have any issue in audio? Rasha?
Clear, sir.
Audio is clear, right?
No issues. Yes.
Clear, sir.
Okay, thank you. So whenever we are going to the class, you must make it very clear what is actually data, what is actually information, what is actually insight. These three terms must be very clear. First of all, maybe some of us are not very clear. We know, suppose I'm saying I'm 18, some value, I'm saying 18. We can say it's a data. It's not an information. When it converts into information, if that data is giving some sense, suppose we are adding one more term with that. My age is 18. Now it makes sense. So from the 18, you got some information. So this is an information. My age is 18 is an information. 18 is just a data. We cannot say what it is. It can be age, it can be rate of some item, or it can be something other parameter. So once the data is giving something extra or information, so we are calling it as information. Data is converting into information. So that is also available with many of the data sets. But the difficult task or the contextual task is something we are calling as insights. So what is insight? That also we have to understand. 18 is there, my age is there. When a context is adding into this particular field, the context is added. Based on the context, the person can detect something from that. Suppose I'm a ward member. Imagine I'm a ward member and I got the idea that this person's age is 18. So what will happen? I immediately ask him to. So immediately we are asking him to go and enroll for voters. You have to get vote in the next vote. So go and enroll in the voters list. So the context is related to that person. Suppose I am a ward member, I will do that. Suppose I'm a person who is running something like what I can say, driving school. Imagine a driving school. The context is different. My aim is to make him apply for a vote. License. So the context is changed. So based on the context, we are deducting something from that. Data is common for both the ward member and for the driving school owner. Both of them got the same data set, and it's his responsibility to utilize it in a way which is favorable for him. So this is what the insight. So make them understand these three terms are different, and the real difficult task is residing in finding the insights from the data set. So where we can see a variety of data sets and variety of data in many places. So normally we'll say structured data, unstructured data, and semi-structured data. I'll share the link with the, maybe time is there, I'll show the examples. So the structured data you can see from normal CSV files and all. Semi-structured data, maybe few people may not work with semi-structured data. So normally we can see something like, what you can say, a kind of key value pair like JSON files. Some part will represent one attribute or like one column, and the other part will represent the other column. So it is not exactly organized, but we can make it organized. There is no much difficulties like HTML and all. We can find the way to convert or pattern identify, and we can convert into the structured format in an easy way. So it's a kind of semi-structured. And there are data which are unstructured, like PDF files or images or audios, or we can see text files. So these kinds of data, we have to make them clear, because they are the students and they may not explode what is actually structured data, unstructured data, and semi-structured data. So you try to make them understand with a small data set. That will help them better to understand what these things are. So here we have to explain a lot of things. Whenever we are working with the structured data, your time will be very, we can say a lot of time, because all the data are structured. We just need to think of the insights, what kind of insight we are trying to build, or what kind of idea we are trying to prove. So that way you can focus. But if you are dealing with a kind of unstructured data, it's really difficult, really very difficult to convert that data into a format which is actually processable by the machine learning models. We know all the models can select if we are giving or supplying images, audios, or videos, whatever we are supplying, all we have to convert into zeros and ones. It's not an easy task. It will take a lot of time. So definitely, if it is a non-structured or unstructured data, there we have to invest a lot of time. Feature abstractions, feature selections, or feature engineering, or we may apply to make it very simple and feed the particular data, converted data into the models. Then we are training it, and finally the model will build it. We can use it for the future purpose, and we can retrain it. We can make it better. So this idea we must have. What kind of data the human beings are receiving? What are the formats they are expecting? They are retrieving and they are processing. So the same way system also capable to process all these kind of things. But the thing is, we have to convert all these data into that particular zeros and one format. That is not so easy. In our university, we are learning a separate subject for this particular task. We are calling it as exploratory data analysis. Maybe CSE syllabus may not have, I don't know. While I'm teaching there, it was not there. So exploratory data analysis or extraction, preprocessing itself is a tedious task. It depends on the data type, especially if it is audio or text file, all these things, then we have to focus more on that extraction or feature engineer feature selection task. So this data set also available. I'll share the link. So this is some examples I given. What the human beings are processing, our eyes, our ears, our brain, all these things, we have the system also mapped into all these kind of things, and the examples, how it looks like. Generally, see the structured data given in the first cell, the text data, which is an unstructured format, a JSON small format are given here, a data collected from sensors, IoT sensors. We can see that values, it's actually a numerical value, but the thing is, it actually senses. Smell can be, touch can be, or any other senses, but the reality is it is a numerical value. My research work is actually on this particular area, sensor kind of data I'm retrieving and working mostly on numerical data, but I work one with voice data also. It's somewhat difficult because its features are very difficult to understand most of the time. MFCC, CFCC, many TFTs, all that kind of words are very uncommon, and I have to learn that. I took a lot of time over there. So voice data is also there. We can process it, we can work it, because we the human beings can do it. It means the systems can also learn it. So that way we are learning, or we are converting voice data. Similarly, images also we are converting into different formats, RGB based or whatever the pixel based values. The experts who are doing image processing, they understand what we are actually extracting from the given image. We are not directly taking it. We are using zeros and ones. So videos also, they are GPS kind of values. So all these key things are common kind of data sets, and actually this is what normally we are using. Beyond that, it's very rare. Maybe combinations we can see. It's like we are calling it as big data. But maybe the combination was beyond 3 Vs or 4 Vs or 5 Vs. We are calling it as big data. So that's a different scenario. Tools will different. It's not a machine learning kind. Machine learning is there. But basically for this course, you understand at least these kinds of sources or these kinds of data we will use for teaching them the overall concept of machine learning. So make them understand that we are trying to teach you how we are learning something, and we know how we are learning something. We are trying to incorporate our skills into the system. So maybe system will do better than us. So this is what we are actually discussing for the subject from the data perspective. Whatever we are retrieving, the system can also retrieve. And another important process that we have to understand is how the machine learning process works. Maybe most of the people know the flow of machine learning. But still, I'm giving small example, and we are explaining the different stages of machine learning process. As I told you, whenever we are approaching some problem, suppose related to machine learning problem, first thing is we have to define the problem perfectly. Definition of problem will solve it half. A correct definition why we are solving this particular problem. We may have some goal. So that depends on the goal. We have to collect the data. We are not collecting data, and if we are collecting data which is totally irrelevant or not related to the defined problem, we will end up with a garbage results, or we cannot use it for any other purpose. So we define the problem. Imagine we have to identify a person. You are a new teacher, or you are a teacher new to the class. 50 students are there. Definitely you have a problem to identify one and everyone, or each one of them. How you will identify? It's not an easy task. What you will extract for identifying these students? Generally, we human beings, or general perspective, or general way of understanding the human is with the help of images. But the easiest or generally following way is collect data. So we are going to the class, and the first day itself, you found 50 or 60 students. 50 out of 60 students. Can you remember all 50 students on the next day? I would say definitely no. But you a few of them. Is there any network issue? I got a message like network issue.
No, sir.
Audible, right? I'll change my internet. Now power is there.
It's audible.
So process, what we are doing, we are reading some 50 pages out of 60, and we are unable to identify all the students on the next day. But you can identify some of them. So what you have done? Did you do something extra? But some are easily identifiable, some are not. What you have done is actually a kind of attention based, or you can say you have done some kind of special attention, a kind of feature extraction. You have have done some special features. Somebody maybe sit on the first bench, or somebody maybe colored hairs or long hairs, or some different kind of eyes. So special features will help you to identify. So features are really important. Which feature can easily identify a particular person will be having more impact. So we are collecting a data, and we are not collecting the entire data set or the entire features of the data. We are reducing, or we are eliminating many of the features, and we are keeping only few. So we are using some terms like feature extraction, feature selection, then feature engineering. So sometimes we choose the existing features. Suppose you have 10 features, we can say a face is there, we can extract eyes, eyebrows, forehead, lips, noses, so ears. You extracting all these are separate entities, and we are saying something related to that particular feature on the face. Sometimes that particular feature is different. We are easily identifying a person. So pre-processing is the next stage. Once you collected the data, we have to pre-process it. Don't go with the entire data set. Whichever is really relevant. Sometimes even we need some kind of feature engineering. We have to collect some of them. Some 2 or 3 features we will collect and convert into a new feature, and we will say it is a feature Y or X. It's a new feature. It is not in the entire original data. We created new one by considering some 2 or 3 features. We make it new. So what will happen? The dimensionality will be reduced. Processing time will be improved. Kind of feature engineering, whatever it is, we are pre-processing data, and based on the pre-processed data, we will train the model. Which model to train? Definitely, it's not an easy task. It's not an easy selection. We know the basic models. Was related to regression, we know some logistic, including linear regressions or any other kind of regression models are there. If it is related to a kind of classification, again, thousands of models will be there. Normally, we are using some decision trees or random forest or many other SVM, many kind of classification we can use. If it is related to clustering, again, it is depends on k-means, okay, and k-nearest neighbors or hierarchical clustering. Many clusterings are there. So we have to select the model based on the task, what we want to predict. If we want to identify a person based on his features, we can say it's a kind of classification. We are classifying, labeling a particular person with a name, and we have to identify him on the next time. So once the model is selected, we train the model with the pre-processed data. Now the task is evaluation. Again, it's not an easy task. We will say it's an easy task, but it's not an easy task. Evaluation depends on the kind of machine learning process we are following. If it is a regression task, we have to evaluate the process with the different parameters like mean square value, R square value, MSE, MEE, map score. Many parameters are there. If it is related to classification, we may choose R square, we may choose accuracy, F1 score, sensitivity, specificity. So relate F1 score, many parameters again there. So clustering again, WCSS, inertia, we can say Likelihood score. Many things are there to evaluate the performance. Once the performance are okay, we will go for deploying and monitoring. So what the human beings are doing, the same steps we are also applying. So what actually happens for us? You imagine that you are very confident. You are going through the class for a year or maybe for some 25-30 hours, and we are so confident that I can identify my student on the next day. Suppose they are coming to a function and they are coming totally different dress. What will happen? You may not identify sometimes because of their makeups or because of their dress pattern changes. So it means you are not a well-trained model. You are not able to generalize. You are not a generalized model. You are underfit or you are overfit. You can say in different ways. Depends on the. So sometimes you'll go underfit, sometimes you'll go for overfit, but a generalized model, building a generalized model is really tough task. There we have to be very careful in all these aspects, including the evaluation performance. And the evaluation performance, we are measuring not with a single data set. We have to measure with multiple data sets and ensure that the performance is consistent. Once it is consistent for multiple data sets, we can say it's a deployable model. You can monitor it, but still it is a deployable model. So this flow or pipeline is really very important. Whatever the data set you are opting or whatever the problem you are defining, the entire task, this will be common. Even if you are doing a research, the things will be, machine learning part will be the same thing. So be confident in this flow, and you have to invest more time. Each and every depends on the subject more. So some subject I told you exclusively for processing kind of things. Some will be for optimizations. Subject is there, optimization. So optimization focus on model selection, parameter settings. So all these kind of things. Since you are dealing with basic machine learning, the flow is enough. The flow is enough. What actually happens? We are defining the problem, collecting the problem, pre-processing the data, training the model, evaluating the model, deploying the model. Enough. The way we are learning something. You can take as an example and you can give for the students. They will understand it, the concept. So this is what I explained to you, some kind of examples. So we are saying some general terms. Many times you hear the supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning. These terms are very common and not all of you, but I would like to give a glimpse over the term supervised learning. You know it. Why we are calling it a supervised. An example, we are saying someone, we are holding an apple and we are telling the student that it is an apple. You understand that? He understands that it's an apple. A kind of classification problem. You are teaching him apple with its color, its shape, and some kind of other parameters. Maybe the shape is first parameter, color may be another parameter. The kid knows it. Maybe a small kid, he knows it, it's an apple. Suppose on the next day, you are coming with a green apple. Green apple. Some kids may say it is maybe sabarjila or something different fruit. He may say wrongly. But some kids will say, still he will say it's an apple. Actually, the student learned with a parameter or feature, we can say color. Another feature we can say it's a so somebody will catch both and they learn it. If both are matching, they will say apple. Otherwise, they will not say that. But in machine learning terms, it is not necessary to match the entire thing. We are measuring probabilities, sometimes based on the Bayesian theorem or whatever the model we are using. Based on the number of features, it is not necessary to match all features. We know it. So in supervised learning, it's a kind of teacher teaching method. We will teach it, we label it, and we learn it. So whenever it repeats, we will say it. A somewhat a kind of teacher teaching method. It's not necessary to match everything. That's what I give an example. It is not necessary to match color and shape. Sometimes shape is enough. You can predict it, maybe correct or wrong, but there is a possibility. It will predict. In unsupervised learning, here I given an example of grouping toys on the basis of shape. If you are giving to a small kid, maybe 5 years or 3 to 4 years, they may try to group it on the basis of color or on the basis of shape. So this is a kind of unsupervised bulk of data, but there is a kind of a pattern. And based on that pattern, they can cluster it. There is no supervision, nobody teaches them, but they are able to do that. And another one is semi-supervised learning. So this is the third category. And finally, reinforcement learning. So this is again action-based concept. We know how to learn swimming or how to learn bike riding. So whenever we are training someone to ride the bike, whenever they falls, we will beat them or scold them. Whenever they ride properly, we will appreciate them. Once they get the clap, they feel like, oh, I got appreciation, I got awards. So I have to do it again and again. Whenever you are getting more awards, you try to get it by default. The organization of a brain is like that. We always want rewards. So we will try to get it more and more. So we'll become expert. If you are getting some actions, if you are getting beats, whenever you are going to fell from the bike, you may think of the actions or a kind of beats. You'll try to rectify that. It's not something you have to do. So same way, if machine learning model is getting some kind of negative points or a kind of negative actions, we will reduce the weight over there. If we get the reward, we will increase the weight of that particular thing. So based on these reward actions or positive and negative kind of scoring, the machine learning model will become perfect. So that is a kind of reinforcement learning. So these are more commonly using type of machine learning models. Here the evaluations of these models, I told you, based on the type of task, maybe regression task, classification task, or clustering task, the parameters will change. Some examples are given here. I told you R square value, adjust R square, mean, absolute error. All these are actually how to explain with the help of small data sets or with the help of numeric examples. Simple things, but still, if we are explaining with some examples, we will get more idea. But here, within 1 hour, we cannot cover all these things in detail with examples and all. Even coding also are ready with me, but everything we cannot explain in 1 hour. It's really difficult. So here, I think the new term may be related to the measuring of clustering. We know how we are measuring regression model. Suppose we are predicting your mark or our mark for the gate exam or something. You are predicting something like I will get 32, but you are getting maybe 28. A kind of difference is there. So that difference sometimes matters. So based on that kind of difference, we will change the model prediction model. We are calling it as a gradient descent and all. So the measuring parameter, it is in prediction case, we are measuring mean absolute error or mean square error or root mean square error or fitness of curve, or we can say R square value. Another word is there for R square. So these values are related to the regression kind of things. But in terms of classification, whether he predicted apple or not, how much accurately he predicted, then precision, similarly, how much positive he collected among the overall. So related to these kind of things, we are measuring classifications. F1 score, a harmonic mean will use ROC, AUC curve we are using. So classification task means we have to choose different evaluation metrics. Similarly, in clustering case also, we are going for the core concept. Within cluster, sum of squares, we are using one kind of parameter. But the thing is, the core idea of measuring clustering models are whenever we form a cluster, inside the cluster or inter cluster and cluster distance, these two are very important. Two clusters must be maximum apart. We will say two clusters must be maximum apart. They must be far from the other cluster, maximum apart. Then we can easily identify the clusters. But at the same time, the points in the cluster must be so close, maximum close to each other. So we will feel like they are the cluster. So these 2 points we are always following while we are measuring the clustering models. So that is called inter-cluster distance and intra-cluster distance. So these points is very important in terms of clustering model evaluation. That is what another point to remember. All are important points, but time won't permit for all. Then again, how we are deciding whether it is a good score or bad score. Whenever simple trick is whenever E is coming, RMSE, MEA, MSc, MAPE, all the places you can see E, it means error. So error means definitely it must be low. Always error must be low. We are expecting the lowest errors. So lower will be better. That is a small idea you have to remember. The remaining all like you have to study in detail. So coefficient of determination, R square, that is the only thing that should be maximum. That should be maximum. So that is R square value. If it is 1, perfect. There is no doubt in the predictions. You can exactly say, for example, if a student studies 5 hours, he gets 50 marks. The student studies 6 hours, he gets 55 marks. If he 7 hours, he gets 60 marks. So there is an exact relationship between the hour of studies and mark he is getting. So can get an R square value of 1 perfectly. It can predict. That will be a perfect prediction. Fitness of car will be, the coefficient of determination will be 1. So that is related to R square. Remaining all are error values. So error values must be as minimum as possible. So the best value also, we can check it whenever the scenario is coming, whenever you are doing an experiment. MAPE normally I use many times. It must be less than 10, but maybe sometimes they will accept 15, up to 15 also. The mean absolute error or mean square error is actually depending on the target variable which we are predicting or we are forecasting. So based on that magnitude, it may change. So the lowest will be better for that particular error scenarios. Similarly, these equations and all students are really related, because in the exam point of view, they may give some scenarios and they have to calculate these points. They may give a scenario, they have to calculate confusion metrics, and based on the confusion metrics, they have to calculate accuracy, precision, recall, and F1 score. So the point you have to remember is these are the parameters that we are using for the classification task. And the equation also have to remember, definitely the range will be 0 to 1. All these cases, the value will be 0 to 1, best will be 1. So that is another classification related thing. And again, here also in clustering scenarios, normally people are not giving much importance to the clustering performances, but it's really required whenever we are doing some k-means clustering and all, or hierarchy clustering, it is there in the syllabus. That time you have to be careful. As a student, if you got the Likelihood score of this much, what it means, and which is better, and they may definitely ask within cluster sum of squares. We are normally asking for the examinations are giving some values, and we are asking them to calculate. So this is another kind of measuring clustering models. There are some others also, but normally we are using this is Likelihood score, inertia, and within cluster sum of squares we generally uses. Others are also there. It depends on the context. We can choose the best parameter of measurement. So this here in second. Okay. So finally, we'll wind up with a few more discussions on the basic intelligence scale in real world scenario. We know where we are using machine learning models. There are many examples. While beginning the subject, machine learning subject, you can give some example scenarios or example use cases or where we are applying these things. So students may feel really interesting, but nowadays the students are also aware of the area where we are using machine learning. But the thing is, the AI, they simply say AI. So AI actually, it is actually a kind of if-else loop. We can say it's an superset of machine learning. We can say a superset of machine learning. Inside the AI, definitely they all uses the machine learning concepts. So the recommendation engines, normally we are using, whether it is YouTube or Netflix or wherever we are continuously watching. Any issues there? Somebody is talking. Okay. So in medical diagnosis, people who are going for tumor classification kind of research studies or many medical cases, we are applying bioinformatics as separate branches there. They are all using this medical diagnosis on the basis of machine learning concepts. Voice assistant, we are using smart speakers or Siri, Alexa. All these things, they are working with the help of voice data. So many different types of data are using for building different intelligence in the real world scenarios. And the final conclusion part, what actually so machine learning and AI are the same thing. People are confusing with the term, but it is actually, I told you, machine learning is not actually AI. It's actually part of AI. AI is actually broad field. There are a lot of other things. ML just contribute one part to the AI. So AI always require massive and endless data. Another consumption, we will believe like AI requires massive or endless data. It's not like that. Models will converge easily if they get best data, best quality data in the required amount. So class imbalances may happen. If you are teaching a model with one particular class, we are teaching only apples and we are teaching very less orange category. So maybe imbalance will happen. So they need a set of data, but doesn't mean that an enormous data is required or endless data is required. So many of the cases, the scenario will be same. The particular food will be particular way for overall the whole period of time. Very few will be outliers, but generally the pre-existing knowledge or the smaller focused data set is also enough to build a good machine learning model. Depends on the task and depends on the type of machine learning. It's not always require a huge set of data or endless data. Again, another myth is ML exists to replace human workers entirely. It's not entirely replacing. Actually, it is supporting the human being. It's actually act as a cognitive augmentation. We cannot always think in multiple dimensions. So our intent, we have to scale up. There it will support. Many decisions we cannot take with n number of dimensions, but there it will come for the rescue. It will support you to take decisions with more number of dimensions. It will increase your intelligence or a kind of cognitive augmentation, add something extra cognitive power. And algorithms are flawless or unbiased. Another belief is like algorithms are flawless. Definitely algorithms have flaws and they are biased also sometimes. Garbage in garbage models make errors and they adopt the biases hidden in the training data. Sometimes the training data, I told you, another important problem, class imbalance problems and all. So there are chances to make errors, and based on the data set we provided, you can express some in the data sets. So these are the basic idea I try to convince you, but again, there are some examples and some programs you have to execute and share. And now, after some discussions, your queries and all, we can go for that. And based on the time, we can find out. Shanid sir.
Thank you, sir.
So actually, the time to wind up is 8:30 or 9. Hello. Pasha? Hello.
So you can continue until 9.
Till 9.
Yeah.
So can someone ask some questions right now? Till now, I'm just broadcasting like the radio. So I wish to hear something from your side, then we can continue according to that. Anybody have some doubts?
Participants, feel free to ask any doubts you may have.
So normally, for machine learning models, I told you, whenever we are giving more data, performance of the machine learning model will be increased. That's a general scenario, but it's not universally true. A general scenario. Normally, whenever we are giving more data, you can expect better results. So whenever we are explaining the same thing to the students, you can try to explain with some small data sets. So here I have given some example code. how I should share, either to the WhatsApp group or where I have to share. Prashad, you have any plans for sharing the codes or something? Sometimes they may be interested to execute. Very few may be participating in systems. But nowadays there is no meaning of sharing all the codes and all, because all are available with ChatGPT or Cloud or whatever you want. But you have to understand the basic idea why we are saying some codes or some terms, and we have to justify that. So normally this is something like a small data set I just created in my system. And whenever we are running the same code with a small data set and large data set, we can see how the performance is increasing. I just show the code. For temporary purpose, we are keeping the data set over here in the Kalam. And here we are reading the data set. You can see the see here, first data set is a small data set, and there we are getting an accuracy of only 33. But if you see a large data set, you can see it's like 1 accuracy. It means perfectly predicting. So normally, if you are giving a good data set and according to the model we are choosing, the performance of machine learning model will increase. That is what the first term which is discussing in your syllabus, machine learning versus traditional programming. Whenever we are giving same input in traditional programming, we can expect same output. But in machine learning, based on the data, it will change. The second topic we are discussing is supervised, semi-supervised, unsupervised, and reinforcement learning. So here, while dealing the subject, one more thing I have to discuss. I've gone through the objectives. Course objective they are mentioned to impart fundamental principles of machine learning in computer science and to provide an understanding of concepts and algorithms of supervised and unsupervised learning. 2 course objectives they defined is very clear. And here, coming into the course outcome, they have mentioned 5 course outcomes, and all of them are covering K2 and K3. It means first unit illustrate machine learning concepts and basic parameter estimation methods. They mentioned it as K2, knowledge level or Bloom's level. I think you all teachers, you know the Bloom's level from the remembering, understanding, applying, analyzing, then developing or creating and all is last 2. So in this subject, we just need to know K2, knowledge level 2, 3 only. Understanding and applying how a particular thing works. And you have to demonstrate that. You have to focus on the theoretical concepts and problems. Beyond that, there is no need to discuss. Actually, according to the theory subject. So first CEO, they are telling like illustrate machine learning concepts and basic parameter estimation methods. It's actually related. So in unit 1, all basic theory, we explain supervised, semi-supervised, unsupervised, and all. Here, parameter estimation part, it may be a little bit different or a bit difficult, I think. So maximum likelihood estimation is actually proper related to mathematics, maximum likelihood estimation. So actually what happened over here is, you imagine that there is a theft happened and police is suspecting someone. They got some features. With the existing features, the suspicious people are there. The features and suspicious people, they will be compared. Who is having maximum probability? So that likelihood, the maximum likelihood that we are estimating just with the existing observations. We have some features and current observation. Based on these observations, which one is more matching? So that kind of estimation, maximum likelihood we are doing in one category. But in case of maximum a posterior estimation case of thing, there we are considering the previous cases. We have some proof, we have some features, and we have current specimen or current observation. But along with that, we will be more realistic. The previous history, previous considered for doing the recent prediction. So that will be more accurate than the maximum likelihood, advanced form of maximum likelihood estimation. That you have to discuss in an angle of mathematics with some examples to make interesting. That is also covering unit 1. Then in case of supervised learning, feature representation and problem formulation. So feature representation, I don't know what they actually meant. There are some VC dimensions and all we discussed in class. But here they didn't mention exclusively what kind of feature represented. Normally we are representing features in different ways, especially like metrics and vectors. So here the feature representation they told. What way of representation they meant, I don't know. For supervised learning, they are telling feature representation. Then a role of loss functions and optimization. That also a kind of topic there. Loss function in the sense we are applying gradient descent and all whenever we are predicting something. We are given an example of we are predicting a gate score of 38 and we got a score of 33. So there is a gap between the expected value and the real value. So there is a loss. So how we can reduce the loss? Our prediction was wrong. What happened to the prediction? Maybe because of our experience, the learned model parameters, y equal to mx plus b for a regression case. The parameters, y is something we are predicting or targeting, and m and c, bias and slope, that we can adjust. How we can adjust? Based on the optimizations. We are trying to optimize it by changing the values. How we can change that values? That value changes we can do with either gradient descent methods or matrix method. These two methods also there that you have to teach mathematically. Gradient descent method is there and the matrix method is there. It's easy method, but you have to teach it. The role of loss function. So the loss function we are trying to reduce as maximum as possible. Then regression they are asking in the unit 1. So there we can expect maximum one problem. But according to the syllabus, they mention it as 2, K2, and they should not ask any problems from the unit 1. Why? Because it is K2. K2 means understanding level, they will check. They won't ask for the problems and all. So regression, linear regression with one variable. Normally a simple linear regression. And sometimes they may go with multilinear regression. Multiple variables will be there. One y will be there, y equal to m1x1 plus m2x2 plus m3x3, etc. mn, xn, mn. So many dimensions, many variables are there. X will be n numbers. And based on these x values, we are predicting y values. Definitely, it's even more complex. There also we can apply the gradient descent method and matrix method. I'll show one example if you are okay to listen. One problem, I just kept it here. Just for the purpose of understanding what actually happens here. It's visible, right? Screen is visible, right, Rasha?
Yes, sir. Screen is visible.
Suppose it's a single linear regression. You have some problem, number of hours you studied, the mark you obtain. So you can see X is there, Y is there, simple linear regression and easily predictable, but still I just want to convey the way of gradient descent works. Initially, we know the basic equation y equal to mx plus c. So, or here they are used instead of m, they use w. So here, initially we assume w equal to 0 and a learning rate assume that 0, 1. So the equation y equal to wx plus b, I told you mx plus c normally we studied. So wx plus b, we are predicting with the help of the equation. So w is assigned as 0 and b is 0. So definitely you will get all as zeros. So totally your predictions are wrong. Actual value 246, predicted value 0, 0, 0. It's totally wrong. Now we are going for the gradient descent method. We are first measuring the error. So error we have to measure. Here we are measuring error with the help of one parameter I discussed. I didn't go in detail. It's mean square error. Mean square error we are calculating by the equation 1 by n summation of I equal to 1 to n yi cap by YI, predicted value and actual value. It's squared difference, mean squared difference. We are finding its mean and we got some value. Here it is 18.67 in the example. Then we are computing the gradients of each and every items. Dou J by dou W, dou J by dou B. So all we are calculating, we got some values. And based on these values, we are updating the parameters. W we are changing. Initially it was 0 and B also 0. After this mean square error calculation and gradient calculation, we are updating the W value and B value with new value. So B is changed into 0.8 and W changed into 1.867. Now your Y cap equation becomes Y cap equal to 1.867x plus 0.8. Based on that, we are predicting again the next prediction. So we are optimized. We identified some errors or loss. We identified based on the loss. We applied gradient descent. We got new values. We reapplied. The equation is modified and Y cap becomes 1.867x dot plus 0.8. Now the value are predicted as this is somewhat matching. So we are trying to plot it. Fitness we are finding the actual is where and your predicted value based on the updation. So we are updating the value with this kind of method, gradient descent method. That's what they are discussing in unit 1. The last topic they are discussing like gradient descent algorithm. And one more method is there, even more easy. That's matrix method. Okay, same question, same, everything is same, but here we are applying one equation that we have to remember: the X transpose X all inverse X transpose Y. This is the only thing you have to remember. Meaning all like similar, but here also we are assuming something at the initial stage. Our goal is to find best value for W and B, slope and intercept, because it's a regression problem. We have to find best value for W and best value for B, the intercept. So by using the matrix method, so we are creating a matrix. Initially, bias we are adding as 1 and input is given 1, 2, 3. Already we have input and Y also given in the question 1, 2, 4, 6. Same question. We are calculating all the X transpose X inverse and X transpose Y. So X transpose X mathematically we know how to calculate value, and X transpose X inverse also we are calculating, and finally X transpose Y we are calculating. So once we calculated that, we have to calculate theta value. So theta value we calculate, and finally we'll get the B value and W value. So this B and W will substitute. We will get Y equal to 2x plus B. So Y become 2x, exactly matching. Y equal to 2x. 1. If x is equal to 1, y will be 2. X equal to 2 means y will be 4. So simple linear regression, R square will be 1. So this is another method. I'm just giving a glance. Why? Because you may be required while explaining to the students in an exam point of view, maybe they will ask, even though it is not mentioned in the syllabus, there is a chance to ask these kind of questions. This is what we are preferring while putting the question paper. This is the only point we'll see. What is the Bloom's level and what is the CEO they mentioned in the syllabus? Based on that, we'll frame the questions. If they are properly following, they won't ask question of the unit. Then remaining units, unit 2, all about logistic regression, naive Bayes, KNN, decision tree, ID3. So here the thing is you will suffer a lot for finishing the topic, because I saw the syllabus, they wrote it like 3003. 3 hours in a week. It's not sufficient actually. Suppose you are doing one problem from each and every case, definitely you cannot finish everything. Naive Bayes itself will take 2-3 hours. If somebody demand means I will give the PPT and all. KNN, almost all of the topics are there. ID3, decision tree, they mentioned ID3. And KNN is a simple problem. 3 hours, and decision tree also will take 2-3 hours. ID3, it will take decision tree. One category only they mentioned. ID3. One more was there actually. CART, CART was there, but they reduced 1, 2, and make it ID3 only. Here, generalization of overfitting. I just given a glance. Generalization overfitting, what actually means, and lasso ridge regularization, how we are applying regularization, training, testing, split. Here and all we can easily cover. classification measures and all we can easily cover. But the problem you can expect here is MEA-based, KNN, and decision tree. 3 problems you have to solve in the class. Then SVM, linear SVM, ideas. SVM normally they won't ask problems, but they will ask the idea how we are hyperplanes, how we are plotting the hyperplanes, actually how it is working. Neural network, maybe you can expect feed forward neural network problems, maybe they will ask. But other than that, activation functions and all, they won't ask much questions. This you can expect a problem, backpropagation and feed forward. These 2 you can expect problems in the syllabus. Then unsupervised part, yeah, clustering means basically hierarchical clustering, agglomerative clustering, both are one category. Hierarchical, normally we have 2. Here they mention only 1, agglomerative. Partition, yeah, both are mentioned, partitioning clustering. Child action, they won't ask problem, I guess, but you have to understand the method, what actually doing there. We may have multiple dimensions and we are trying to reduce the dimension of the entire mathematical process. If you are solving the problem in the class, definitely it will take 3 hours and pages will be around 5 pages. So definitely they won't ask problem from PCA, but they may ask simple questions like 5 mark or 3 mark. If it is there, they can ask. And simple methods, bagging, boosting, theoretically we can teach. So around 6 problems you have to teach. Remaining, you can cover like concepts with theoretical concepts. Lab is also there that they will practice in the class. So this is what I have to discuss with you, and I expect some questions. Prashant?
Participants can ask any doubts if you have.
You can type in chats also.
Sir, good evening.
Yeah, good evening.
Sir, you told maximum likelihood estimator is purely mathematical.
Yeah.
And it is a basic, as a beginner, the students have to learn about that. So from the basic, how we will teach them, whether we require to teach them the conditional probability and other probabilistic functions to make them understand the maximum likelihood.
Yeah, actually, they already learned in S4, I think. Topic in syllabus, I guess. Otherwise, it will be a tedious task. Already they learned MLE, MEA in mathematics, S4, I guess. Once they know the concept, then you can map them. Maximum, it's not that much difficult, but still it's related to mathematical concept. We will suffer more than students. As a faculty, we will suffer. How to convince them? So you
in
got
S4, I think it is an elective subject, I think.
No, probability is there, no?
Probability is there.
S4,
Maths.
S4. Yeah, math subject was there. Math subject was there. Where they learn basic idea. The best thing is you go with some real life example and go with some small problem. That's enough for them to learn for the exam point of view. They have to know why we are going for probability concepts, the likelihoods impact, and MEA how it is altering. That way you have to convince. Don't go for a 10-mark question. Go for a 5-mark question.
Okay, thank you, sir.
Anyone else? What kind of things you are expecting from me? I can share that. If possible, I can share that. The materials, whatever I with me, but not all are same. You are same, but not all. I just show you 2021. I just handled while I worked in MEA. It's 2021 machine learning. CSE. This was the course code. All the modules are there with me, but not exactly same. Notes are there, PPTs are there, text is there. But the thing is not all same means you cannot use it properly. So notes are there. If you need these things, you can ask the coordinators. I'll share them in a drive. You can utilize it. So syllabus is almost same, not all. That time it was 6 years. 6 years are there and 6 units. So this is how we maintain 6 units and 6 years. That's why it is different. Yeah, I'll share it with Sandy sir. I will share with coordinator. I will share it and he will share you maybe at the end of all sessions. Utilize it because it is not exactly the same syllabus. Different way you have to organize. Nowadays, it's not that much difficult to find the materials. I think you are all using LLMs. Notebook LLM you are using, right? Notes definitely I will share you. Any other comments you can see? PPTs and notes I will share. Definitely I'll share. It's only 9-hour content and it's 1 hour I just finished. Even I prepared my GitHub link, Collab, normal system code also I prepared, but this time is not sufficient. For MEA FDP, I created all these things. Codes are also prepared, but explaining the concept itself takes 1 hour, 1 hour plus. So I told him it's like a workshop. You have to go there, you have to be with them. Then okay, you can cover all topics. 1 hour and the foundation is not exactly sufficient, but you will get some idea. Whenever you are teaching any concept, try to map with the real life. They will listen, they will understand. That is the best way. Any other things? Not, I got the comments like to share PPTs and notes. Definitely I'll share. And one RAR I'll compress all and I'll share. Any other things? Dasha?
Yes, sir, I think we can conclude.
Yeah. Yeah, somebody is asking software is required or not. No, it's actually not required because it's normal ML. We are teaching students with very small data sets. And the best part is most of the data sets are available in the libraries itself, Scikit Multiflow or some sklearn. So many places you can see default data sets. So we don't even download it. But the best thing is you try to learn the things with Visual Studio Code or in the local system. If you are starting machine learning, start with your local system. VS Code and all. Here, whatever I'm doing here, the same there. VS Code I'm using as editor. You can use any editor, but try to code with your local system. Then you move into Colab. If you are using Colab, the problem is you will never learn the settings. The settings will be totally unknown for you. So sometimes you cannot survive. The GPU is not required in many cases. If you are going with very large data sets, may be required. That also they will provide. Colab will provide up to an extent. And for these lab cases, all of them you can execute in normal systems or in Colab. University examination, I don't know the pattern over there, how they'll conduct. In university examination, I think they won't provide internet, right? Internet will not be provided, no, for university exam. Okay, Jupyter Notebook is also fine. Fine. Jupyter Notebook is also fine. VS Code is also good. I prefer VS Code, and in the backend, I'm using Jupyter Notebook. Somebody will use the Jupyter Notebook as editor as well as the Python will be installed background. So Jupyter Notebook, fine. For me, even though I am using VS Code, my background is Jupyter Notebook only. It's just an editor. VS Code is just an editor. Background, it is Jupyter Notebook. You can see mine. If university will not allow you to use internet, definitely you have to go with system installations. All packages you have to install. That is the only solution. So this is what spider also fine. Spider also you can use. So whenever we are setting environment, we have to choose the kernels and all. Here it is automatically entering. Otherwise, you have to create an environment. There you code everything. Because if you are doing everything in different places, many times you will feel like your Panda is not supporting for this case. You have to upgrade Pandas in so and so versions. So the compatibility issues will come. So better you go with virtual environment, and in that virtual environment, you choose whatever the package they're demanding. It's not always possible to go with the same Panda version, same number version, but you have to change it. So this is how it looks like, because its background is Jupyter Notebook only. Front end is VS Code and background is Jupyter Notebook. This is just a pipeline I just created for you, but time is not sufficient. So university exam, if they are not supporting internet, definitely you have to go with local desktop systems, and you have to download datasets. Some you have to download, some will be there in the packages. You have to install it and you have to do it. Lab instructors will support you. Anaconda, somebody uses Anaconda, but I never use Anaconda. Only once I installed, my system got hung. It's very heavy for my system, so I uninstalled and I move with this Jupyter Notebook plus VS Code. Anaconda, somebody are using Anaconda. Yeah, data sets, just a minute, I'll check it. Data sets, whichever is available, which is not available. I guess all data sets will be available. Even if your data set is not available, we can create it. But here they will mention available data sets only. UCI repositories or Kaggle, many other places, which is that much heavy data set. I didn't see. They are not mentioning dataset names here. Initially, I saw MNIST is available by default. It is there in the library. First two also in the library. ID3 they didn't mention any dataset. Logistic regression, adult income dataset will be available. Yes, they didn't mention dataset. RPF, SPF, again MNIST. So handwriting related dataset is also available. All these datasets are available. Don't worry about dataset. You can get it. Intel Core i3 will be enough. I'm using i5. i3 will be enough. Suppose we are not getting enough resources, sometimes we can use Kalam. Really difficult things. i3 it will work. These programs will work in i3. Any other questions? PPT you asked that I will share all the materials that whatever I used. No other things to share, right? So Rasha, shall we meet up?
Thank you so much, sir, for taking the time to be with us. With a short time, you explained the concepts very clearly, and thank you all participants. And thank you again, sir.
Welcome.
Participants, don't forget to fill the feedback form. The link is shared in the chat box.
So thank you all. I'm leaving the meeting.